Welcome to the Data Memory course of the HT8 MCU Basic Tutorial. This course will take you through the data memory of the HT8 MCU from the following three aspects: data memory introduction, data memory structure, and data memory application. Data memory introduction. What is a data memory? The data memory is a volatile area of 8-bit wide RAM internal memory. It is used to store both the data required to operate the MCU and any temporary data generated during operation. Data can be read and written to this memory, and the speed is very fast. The stored data cannot be permanently preserved. The data will be lost when its power supply is removed. Data memory structure. The data memory is subdivided into several sectors, all of which are implemented in 8-bit wide RAM. Each of the data memory sector is categorized into two types. Take the HT66F3195 as an example. The first type is the special function memory, whose address range is from hex 00 to hex 7F in sector 0 and hex 40 in sector 1. This area of data memory is where the special function registers are stored. Most of the registers are both readable and writable, but some are readable only. Note that for locations that are unused, any read instruction to these addresses will return the value hex 00. The second area of data memory is reserved for general purpose use, whose address range is from hex 80 to hex FF in sector 0 to sector 3. It is mainly used to store data. It is a readable or writable memory area where temporary data can be stored and retrieved for use later. All locations within this area are read and write accessible under program control. This general-purpose data memory has 4 sectors, with a capacity of 512 multiplied by 8 bits. Different MCUs have different data memory. Refer to the datasheet for details. The data memory is divided into multiple sectors and supports a variety of read and write methods, including support for direct read and write, indirect read and write, and assembly extended instructions. Special function registers are used for functions such as configuration, status checking, and other purposes. They are described in detail in the relevant sections. It should be noted that special function registers should not be used as general-purpose registers. Data memory application. Before describing application examples, let's learn how to implement indirectly addressed and memory pointer registers. The indirect address register is used to perform corresponding read or write operations on the specified memory address. The indirect address registers include IR0, IR1, and IR2. The memory pointer register is used to point to the memory address. The memory pointers include MP0, MP1L, MP1H, MP2L, and MP2H. They always appear in pairs. IR0 together with MP0 is used to access data from sector 0, while MP1L, MP1H together with IR1 and MP2L, MP2H together with IR2 are used to access data from all sectors. The MP0 register is used to point to the desired address in the sector 0. The MP1H and MP2H registers are used to point to the desired sector. The MP1L and MP2L registers point to the desired address in a specific sector. The indirect addressing registers, IR0, IR1, and IR2, although having their locations in normal RAM register space, do not actually physically exist as normal registers. As the indirect addressing registers are not physically implemented, reading the indirect addressing registers will return a result of hex 00, and writing to the registers will result in no operation. Indirect addressing allows the use of an indirect addressing pointer for data operations, replacing the direct memory addressing method that defines actual memory addresses. Let's learn about the common methods of variable definition. How to define a variable. There are two common methods. The first one, the variable 1 is defined and the address is automatically assigned by the compiler. The advantage of this approach is that it simplifies development and ensures program portability. The second one defines the variable 2 and also assigns the variable 2 to a specified address. This approach is mainly used for hardware register mapping, memory management, and other situations. How is variable array defined? The first one, the variable array, array1 is defined and the address is automatically assigned by the compiler. The second one defines the variable array, array2, and also assigns the array2 to a specified address. How is general-purpose data memory used? Let's understand the example of writing and reading data to address HT8 located in Sector 1. The following provides direct and indirect read-write examples for reference. The direct read or write method is commonly used for accessing fixed addresses. Firstly, variables need to be defined. Define the variable 1 and simultaneously assign a specified address to variable 1. Define the variable 2. If there is no need to specify an address, the address can be assigned automatically by the compiler. Next, write the data. Write data hex 02 to variable 1. How to read a data from it? The data can be read by making the variable 2 just defined equal to variable 1. The indirect read-write methods commonly used in scenarios that require dynamic access to memory addresses. Firstly, variables need to be defined. Define the variable 3. If there is no need to specify an address, the address can be assigned automatically by the compiler. Next, write data. First, specify sector 1 by using the MP1H register. And then specify address hex 80 in sector 1 using the MP1L register. Then, write data hex 02. How to read a data from it. First, points to the address where the data needs to be read. Then read the data. At this point, variable 3 is equal to hex 02. Next, let's learn about the special function data memory application example 1. Configure the WDTC register, which is located at address hex 1A in sector 0, is commonly done by direct read and write methods. Taking the HT66F3195 as an example, how to set the watchdog timer's overflow period to 512 milliseconds. The first step, select the divider ratio according to the overflow period. The second step, the WDTC register is set to 01010011 through the program. If using the direct read and write methods, just assign the value to the WDTC register. Let's learn about the special function data memory application example 2. Configure the EEC register, which is located at address hex 40 in sector 1. The configuration is commonly done using indirect read and write methods. Taking the HT66F3195 as an example, configure the EEPROM memory for read operation by using the indirect read and write method. First, points to sector 1 where the EEC register is located, and the specific address of the EEC register. And then select byte read mode, and enable the read control bit. Then, initiate the read cycle. Course summary. In this course, we have learned about what is a data memory and data memory structure. You will have a clear understanding of the data memory. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.